This pump that we did today, the Scum Pump, is a rotary load pump. So that's classified as a positive displacement style pump. Positive displacement pumps take cavities of liquid. We have positive displacement blowers as well, so it could be air. But in this case, we're talking about pumping liquids. So it takes a cavity of liquid and pushes it down the pipe length, essentially, all right, from suction to discharge. The interesting thing that you need to remember specifically about positive displacement style pumps, whether it's, and there are a variety of them, it could be just like we have here, a rotary load pump, it could be a progressive cavity pump, it could be a peristaltic hose pump or tube pump. As it pushes, it overcomes pressure, but it builds pressure in your line. So if you have a closed discharge line or a closed suction line, you're going to have some problems. We did what we call deadheading the pump to find the zero flow point, to reach the pressure and build a pump curve off of that. Make sure in this case that you don't have the discharge closed or the suction line closed, because what you'll do is you'll build pressure until the point where pipe fittings connections can burst. Vogelsang is the manufacturer. They are out of Ravenna, Ohio. German technology. This is Vogelsang USA that we're talking about, but the technology comes out of Germany, which is where the parent company resides. You guys have what is called an IQ pump. The rotary load pump utilizes two kind of twisted tri-lobes that spin together, all right? And they spin outwardly along the case, and they take those pockets, they send, from the suction to the discharge. The IQ pump is kind of neat because it makes it very, very easy to service. So looks a little different if you've ever worked on, rotary load pumps in the past. In this case, it makes it very easy to work on because the case is bumped out. So when you pull that casing off, you're automatically right at the lobe, which is right on the shaft. So everything becomes very, very easy to work with. There's a run dry without damage. Vogelsang pumps are warranted against damage for a run dry for a period of up to 30 minutes. Pulse-free operation. It's a volumetric feed when we talk about positive displacement style pumps and rotary load pumps. Whatever speed you operate this at, in theory, you're going to get a linear output. So we'll show you what those curves look like as well. It's a scum application, so you're using it to draw down your scum wells. Over time, they work on clearances. We talk about those lobes that spin outwardly. As they wear down, your tolerances between your lobes and your case spread. And what happens is pressure on the back end of it will allow liquid to kind of seep back through it. So it'll leak back through it and your efficiency goes down. So your pumping capabilities go down. So you end up, what you'll find is, okay, well, I was operating at 30 hertz before. Now I'm operating at 40 hertz. Now I'm operating at 50 hertz. Okay, well, now I'm not getting any flow through the pump. That would typically be a sign to us, not, hey, I'm not getting any flow, but it would typically be a sign to you, at some point as you're losing capacity to say, okay, well, something's going on with the pump. The parts are worn. It's time to order some new parts. That's when you would call me and say, hey, look, here is the model number, IQ 112-114. Here's the serial number on it. The most important thing, I guess, is really your flow range for this pump. 2 flow rates for the 2 different applications you have, which one is Scum and the other one was, you can change the valving.
Valving you can send to the MLSS.
There you go, MLSS.
Or back to the head of the plant,
There it
the
is.
influent pump station.
So you can send it to either. There were 2 applications and they called out 2 points, 40 GPM and 80 GPM. So what Vogelsang did was in their testing, and we just kind of tested it out as we were there as well, they geared it down to cap out essentially at 60 hertz. At about 310 RPM, so you can get up to about 87.6 gallons an hour. And as we go down the line, you can turn this thing way down and still get flow through it, as long as the lobes are, aren't super worn, down to a very, very low number. So you guys are running on a VFD. We tested it out and got some points, 60 hertz, 50, 40, 30, 20, make sure we're getting a consistent volumetric flow. We'll plot that on a curve as well. But that's exactly what you're going to get. The slower you turn it down, it's going to be a linear curve right down here to your top point at 60 hertz, which is going to give you about 85 gallons a minute. All right. You have a flooded suction on them. Again, we can run them dry. I wouldn't run them dry overly too long, as anytime you run something dry and run the risk of building heat over time. Again, these runoff tolerances, you can burn up your mechanical seals, your bearings, things like that. Sequence of operations, like we talked about, because it's positive displacement pump, make sure all your suction and discharge valves are wide open before you turn the pump on. Ensure completion of all startup checks on the table and engage the pump. Ensure normal operation parameters, and then on shutdown, just observe any riseries in the chart. In your pump, you have 2 oil chambers. They're right next to each other. So you'll notice this here, this is for the mechanical seal. This is what we call our buffer fluid chamber or buffer oil chamber. The buffer oil chamber, and then your bearing, oil as well on here. On the bottom, they're each right next to each other. This is your bearing over here, your fill line, and then your drains for both of them down at the bottom. The buffer oil chamber doesn't have a fill line because you basically just fill it directly from the oil chamber. Now, the important thing is we want to make sure we have pressure on the mechanical seal that's overcoming your line pressure. You take an idea of what you have in the specification for discharge pressure, and then we add about 15 psi to it to make sure that you're overcoming it. Now, in the factory, they test these and they make sure they're held, to like 4 bar, so 4 times 14.7 is almost 60 psi, right? So you can over pressurize these. I mean, you don't want to over pressurize to the point where you're overcoming the seal and you're pushing it too far. My rule of thumb is a little more pressure is better than a little less pressure. All right. So this is one of those things you're going to go and take a look at when you go down on, your checkouts, doing your rounds and taking a look at the pump, listening to it and things like that. You're going to want to see this because on this, like we talked about here, on your buffer fluid, again, it pushes oil directly in your mechanical seal chamber and you put pressure on it. It's a can compressor or bike pump and you pump it up to, I think we left it set to just about 2 bar, a little bit underneath it, about 25 psi or so. Make sure now if you see that line on it start to drift down, then you could have had like a pressure spike in your line or something that overcame the seal pressure, that it dropped it back down, or your mechanicals, that's your first indication that you're having a mechanical seal failure. If you start seeing that liquid level go down all the way, right? Like then you're probably losing your mechanical seal, time to replace it. This is what's going to keep your mechanical seal healthy for the most part. All right. So make sure if you go down, pressure gauge hasn't moved. If it has moved a little bit, just pump it back up to where you want it to, and then just leave it, set it. If it starts to really not hold the seal, give me a call. We can kind of work through it. You might have a seal failure. It might be time to change the seal. A service manual just talks about, tightening mounting bolts, check the buffer oil chamber, initial startup, check it after 20 operating hours after initial startup, and then every 200 operating hours. Again, my rule of thumb is just to say, hey, look, when you go down there, right, you're going to be making rounds at least once a week down there, I would think. Just check it out and make sure that, the pressure hasn't changed too much. Make sure that it's properly lubricated, spinning correctly. Gauges are really just kind of cutaways to show you what these pumps look like internally. All right, so again, we talked about that case on the front that comes right off. The shafts stick right out with the mechanical seal behind it. And then the lobes sit right onto those shafts with the wear plate, that connects right to it. So you can tell, again, when you open this pump up, it's really easy to work on right in place there because everything just basically sticks right out for you. Again, you guys are probably going to pick, what your flow rate is, what's not going to pump your scum well down too fast, dry, but it's going to be a good speed for you that you're not waiting forever either. So I would imagine that you're probably going to select that point on your VFD, and it can really be anywhere, from 15 or 20, hertz up to 60 hertz.
We got an ultrasonic in the scum well,
Perfect.
probably about 2 feet off the bottom, 5 feet to keep a small volume in there so it doesn't go bad.
There you go.
And then we've got low float and high float.
Yep.
Should the ultrasonic fail, it'll jump to the floats around.
So then you guys don't have to do anything. Well, if they pop up
the
again, let me
system
know.
down there, we've got the pump, the 2 valves. The one that goes left goes to influent. The one that goes right goes down the MLSS pump.
Yeah, nobody told me that.
Through the we go through the flow meter there. Then we've got the big plug valve in the line, increases to the 8-inch, 6-inch, or whatever, and then goes over to the MLSS. All the time, so pump line probably about here. We'll run a column up 5, 6, 7 feet. I don't want it to fill all the way up to the pump once every week or something. Just like let it come in. It's in there. There'll be a little leakage on the first couple of valves, and then it'll come back in here through here. Discharge of it. We've got 2 valves. One will open. I don't manually upstairs where you want to discharge to. This will be the valve that kicks it over to the influent pump valve, and second valve there will take it over to the MLS.
So how often are you going to be going over to MLS? So my point is, if it is going to be that high, we want to bump that up, the pressure rate.
It's not going, we're not pushing it up 78 feet.
All right. If it were 78.4, now we're at 33 or 35 psi.
And where you at right now?
Right now we're about 25. So we want to make sure and go up closer to probably 3 bar up there rather than 4 bar. All right. So it doesn't hurt to pump it up a little bit more, just based on that condition point. Probably bump it up to 2.5 bar. Rather than that 2.5 bar. So we're talking.
Can we do that before we do?
Yeah, well, I can tell these guys. All it
Oh,
is
okay. Yep,
essentially it's a bike pump. So you just take this.
okay.
Open
And
it up.
who was here, Jesse was here?
All right, so we'll leave that at 2.5 bar. That's going to give you a little bit more wiggle room in case, in case you have some high pressures there. Yeah. All right. So we'll tell people to do that, but it's simple as that. And then, as far as this buffer fluid tank goes, right, this is a good level. It's an opaque fluid chamber, right? So the oil is right up to here. If you were filled up to here, it's a little bit too much. But as you're down here, you really can't see if that's the difference. So really try to keep it in this range. That way you can tell, hey, if the liquid's going down, it's got to be going somewhere.
And then the discharge comes down along here on the pipe. So what we'll do, we'll come down through, go through the flow, we go there, bring the Scum over there, plug valve, right hand in with the plug valve, and over, then we can bring in wires. If we need to discharge, we'll throw wires over there too. So this will always remain, I don't need no condition, close that. But we've got the valve there, pump starts, that one valve will open. There's no valves over at the MLSS tank or anything like that, so. And once we fill it up, we'll play with the telescope and valves. I've got an elevation set, right now I've got them all the way up, so we won't discharge water in there. But you could have a little bit of leakage around the seal there, so over a period of time, I think someone will put down in there, it'll get over to the stomach. But like I said, it'll never come out of the stomach, well, it's higher than the tank. So it would just come up in here and even out and wouldn't get in.